that comes to mind. There's a lot of work that's going as people combining video and graphics and the camera pipeline. The camera is core to quite a few parts of the user experience, so people are using the GPUs to start doing image pre and post-processing, for example. Another area that's very interesting with gaming, which is typically the application that drives graphics performance, is using the GPU now for the physics and a lot of the computation intensive stuff. The beauty of putting it onto the GPU is that if you write the code in the right way, it will scale. So not only will you offload the CPU, which makes the whole phone and tablet and so on more responsive, but as you move through the generations, the whole application will just scale up. And this is the great thing, is the GPUs being parallel processors, whenever you move to the next process, you put more silicon area, then it scales very, very efficiently because they're parallel engines. Sequential engines are great and CPUs are wonderful, but they've reached their limit of how much speed you can get out of it. Beyond that, you've got to go parallel, and that's why GPUs are the future of heavy lifting processing in all of these consumer devices.
Three things I think really come through. One is the visualization of all the games and all the content is really important to users. So we do think graphics is really important. That's why we have our own graphics, the Mali 658, 604, the whole Mali family we think is really important. And it's really about visualization, about content coming to life on a whole raft of platforms. So yes, we think the software is important in that area. We also think the hardware is important, and we think ARM has the best offering in both of those areas.
If you imagine a simple scene, a monster behind a wall, our architecture is always able to identify that the monster is hidden by the wall, so we only process the pixels within that wall. If we look at competing architectures, they use something that's called early Z. The problem with early Z is it's submission order dependent. What that means is if you submit the monster first and then you submit the wall, you will first draw the whole wall, either in an immediate full screen way or in a tile-based way, and then you will overdraw those pixels with the wall. On the other hand, if the developer does a lot of sorting work in advance and recognizes the wall is closer to the camera and submits that first, you can then optionally skip the processing of the monster. But the key thing within our architecture is we don't care about the submission order, because we process all the depth information first before giving that to the shading logic within the design.
We announced Big Little on the CPUs. We also do multi-core and Big Little in GPUs as well. So for us, all of this multi-core technology, reducing the bandwidth going between all the cores, allowing really low power, high performance cores, allowing all of that to come together in a package that's easy to program and easy to use for graphics designers.
Hey, we designed PowerVR architecture from day one to be integrated on chip, and where its focus was on performance per milliwatt and per square millimeter, not just raw performance. The graphics industry historically has been driven by performance at all costs, and you throw whatever technology you've got at it to make that happen. PowerVR started with this industry in mind, and that was why by the time the whole smartphone industry started maturing, we were well prepared with a very, very mature 5th generation technology, with 4th generation with MBX, and then with the 5th generation with our SGX cores. So we're fundamentally designed purely for this market. However, because of the maturity of the architecture, we're now finding the scalability of our architecture enables us to take us to all levels of GPU performance.